All right, guys, so we're going over the review sheet. Need the review sheet out. We can go grab one. Yep.
Awesome.
So problems 1 through 3, we want to state the degree and leading coefficient. So if we look at number 1, what would the degree be? Because the degree is the variable with the biggest exponent. So 8x to the 8, degree would be 8. Leading coefficient would be negative 27. The leading coefficient is the number in front of the variable with the biggest exponent. Since x to the 8 was our variable with the biggest exponent, negative 27 would be the leading coefficient. Number 2, what would the degree be? Leading coefficient. Number 3. And leading coefficient is any other questions on 1 through 3? Four through 7, which one do we want to look at?
5.
Number 5. All right, guys, focus in. Number 5, 4 through 7, evaluate each of the function. Evaluate each function for the given value. Number 5, so we want to evaluate g of x when x is negative 7. So what we're going to do is replace every x in g of x with negative 7. We're going to replace every x in g of x with negative 7. So we have negative 7 to the third plus 3 times negative 7 squared plus 5 times negative 7 plus 1. And then, guys, focus. We need to plug this in to the calculator, and we can let the calculator type the whole thing into the calculator, replacing every x with negative 7. Hit enter, and it tells us that it's 456. Any other questions on 4 through 7? Problems 8 through 10, determine if each of the function is a polynomial. Determine if the following function is a polynomial. Now, all right, guys, focus in. 8 through 10 and 1 through 3 on the test are going to be put together because it's going to ask you to determine if the following function is a polynomial. If it is, state degree and leading coefficient. So if it's a polynomial, we state degree and leading coefficient. If it's not, we say it's not a polynomial function. For number 8, because we cannot have a variable to a negative exponent, we cannot have a variable to a variable, we can't have variables in exponents, we cannot have a variable to a fractional exponent, can't have a variable in the bottom of fraction, can't have a variable in a radical. Now, because we have x to the negative 1, this is not a polynomial. 8 is not a polynomial function because we have x to the negative 1. Number 10, because we have x to the 1/2. This is not a polynomial. If it's not a polynomial, we just say not a polynomial. Number 9, Each of our variables does not have a variable in its exponents. The variable's exponents are not negative, are not fractional. We do not have a variable in the bottom of a fraction. We don't have a variable in a radical. So we can say, yes, this is a polynomial function. On the test, we would have to state its degree and leading coefficient. And the degree would be 3, and the leading coefficient would be 6. As on the test, if it is a polynomial function, you just state degree and leading coefficient. If it's not, we just say not a polynomial. Questions on 8, 9, 10? Are you ready for the next ones? So this here, I will put it back up. You can come back to it. But this is kind of the list of what we're looking for to determine if it is or is not a polynomial. When you come back to it, I can put that back up again later. 11 or 12? Which one do we want to look at?
12.
12. So we want to simplify this here. We want to add these two expressions together. Now, because our first expression, there's nothing in front of that parenthesis, there is no sign, there is no number, we can just rewrite in that first expression without the parentheses. So 12x to the fifth minus 3x to the fourth plus 2x minus 5. There's nothing changing it. There's nothing we're applying to it. Now our second set of parentheses has the plus in front of it. That plus is not going to change the sign of any one of these terms. They're going to be the exact same, so we're just going to rewrite it as plus 8x to the fourth minus 3x cubed plus 4x plus 1. Once we do this here, we've resolved the parentheses. We're going to combine like terms. Always start with the variable at the biggest exponent, our 12x to the fifth. Now, because there is no other x to the fifth terms, there's nothing to combine with it. It's just going to say 12x to the fifth. Our next term is our x to the fourth, and there are two x to the fourth terms. We have negative 3x to the fourth and 8x to the fourth. Negative 3 plus 8 is going to be positive 5x to the fourth. Our next term is our x cubed term, and we do only have one of them, our negative 3x cubed. Because there's only one of them, there's nothing to combine with it. So we just rewrite it as negative 3x cubed. Our next term would be our x squared term, yes? Well, do we have any x squared terms? No, because there is no x squared term, we just move on to x. We have 2x and 4x, and 2x plus 4x is plus 6x. And lastly, our constant terms are negative 5 and 1. Negative 5 plus 1 is negative 4. So telling us that the final answer for this here is 12x to the fifth plus 5x to the fourth minus 3x cubed plus 6x minus 4. That's our final answer. Questions on 11 and 12. Questions on us adding two expressions together. Do we want to look at 13 or 14? Now 14, we're not adding, we are subtracting. Now when we're subtracting, the first expression is still going to stay the same because there is no term or number in the front of that first set of parentheses, so we can just drop those and we are good. However, our second expression, we've got to apply that negative all the way through. And really all that's going to do is switch our signs. Our 2x to the fourth is going to become negative 2x to the fourth. Our positive 6x cubed is going to become negative 6x cubed. Our positive 2x is going to become negative 2x. And the negative 9 is going to become positive 9. We've got to multiply that negative through. And after we multiply that negative through, we're just going to combine like terms just like we did with addition. And the terms I would start with first are our x to the fourth terms, our 11x to the fourth and negative 2x to the fourth. X to the fourth minus 2x to the fourth, 11 minus 2 is 9x to the fourth. Our next term would be cubic. Well, there's only one cubic term. It's our negative 6x cubed. Since it's the only one with x cubed, we just list it next. Then we move on to our x squared terms. We only have one of them. We have the negative 9x squared. And since there is only one of them, we just write negative 9x squared. There's nothing to combine with it, so it just comes down. Our next term would be our x term. We have 3x and negative 2x. 3x minus 2x. 3 minus 2 would be positive 1. So we're going to say plus x. And lastly, we have 11 and 9, our constant term. 11 plus 9 would be 20, giving us plus 20. So when we subtract these two, we get 9x to the fourth minus 6x cubed minus 9x squared plus x plus 20. And that's it. Questions on addition or subtraction? All right, we're going to look at number 15 with our multiplication. When we multiply two expressions, we just need to distribute. So for 15, we're going to multiply each of the terms inside the parentheses by 6x cubed. So the first thing we're going to do is 6x cubed times 2x squared. Well, our 6 times 2 is 12. X cubed times x squared would be x to the fifth. Because when we multiply like bases, we add the exponent. So 3 plus 2 is 5. Now we're going to do 6x cubed times negative 27x. Well, let's just let the calculator do 6 times negative 27. That tells us negative 162. So we do have negative 162. Now our x cubed times x is going to be x to the fourth. When you're multiplying these here, do not put the variables in because both of our calculators, the 30xs and the 84 plus, need a value for x. And whatever the last value that was inputted in for x is what it's going to take. Most likely that's going to be 0. So if you try to type 6x cubed times negative 27x into the calculator, it will tell you that it's 0 because it's going to take x as 0, not as a variable. So if you want to do this in the calculator, we can do 6 times negative 27. We have to do the x cubed times x ourselves. And lastly, 6x cubed times 4. 6 times 4 is 24. And we still have our x cubed. Questions on this so far? Now our 12x to the fifth, negative 162x to the fourth, plus 24x cubed. None of these are like terms. So we're done. That is the answer. If there is nothing to combine, that's it. Questions on number 15? Let's look at 17. Trinomial and a trinomial are 3-term and 3-term. When we multiply these together, first thing I would do is distribute that first term, the 3x cubed. So we're going to do 3x cubed times x squared. We'll still have the 3 because 3 times the number in front of x squared, 3 times 1 is 3. X cubed times x squared would be x to the fifth. So we get 3x to the fifth. 3x cubed times negative 2x. 3 times negative 2 would be negative 6. And x cubed times x would be x to the fourth. Then lastly, 3x cubed times 1. Well, that's just plus 3x cubed. If we're multiplying it by 1, we just get that number back. And now that we've multiplied each of the terms in the second expression by 3x cubed, we do it again, but this time with negative 9x. So we're going to do negative 9x times x squared. And that would give us negative 9x cubed, because negative 9 times 1 is negative 9. X cubed times x, or x times x squared is going to give us that x cubed. Then we'll move on to negative 9x times negative 2x. Negative 9 times negative 2 is going to be positive 18. X times x is x squared. And lastly, negative 9x times positive 1 but just negative 9x. So that's it for negative 9x. Now we've got to do it one more time with positive 7. And 7 times x squared is plus 7x squared. 7 times negative 2x is negative 14x. And 7 times 1 is going to be plus 7. So we have to distribute all the way through with each of the 3 terms. And then lastly, we need to combine like terms. I always start with the variable with the biggest exponent. 3x to the 5th is our only term with x to the 5th, so we just bring it down. Our next term would be our x to the 4th term. Well, the only one we have is negative 6x to the 4th. So we're also going to bring it down because there is no terms to combine with it. It's still negative 6x to the 4th. Then I would move on to our x cubed terms. Now, incidentally, they are right next to each other. So 3x cubed minus 9x cubed, 3 minus 9 is going to be negative 6x cubed. Our x squared terms aren't next to each other, but we do have 18x squared and positive 7x squared. 18x squared plus 7x squared, 18 plus 7 is going to be plus 25x squared. Now that we finish combining those, we'll move on to our x terms, negative 9x and negative 14x. Negative 9 minus 14 is going to be negative 25x. And then lastly, we have our constant term, and 7 is the only constant term. We just added on. So we should get 3x to the 5th minus 6x to the 4th minus 6x cubed plus 25x squared minus 25x plus 7. Questions? Questions on multiplication? There aren't any like 18 and 19 on the test where we're having to multiply 3 things together. Not that it's not useful, it's just time consuming.
Wait, how would, was it 9, negative 9x plus, or like, yeah, the plus negative 14x, how would that work?
So the negative 9x minus 14x? Negative 23, yes.
Oh, wait. I was like,
Yep, nope, I got that wrong. It'd be negative 23. Yep. Nope, negative 23. 17. Yep, negative 23x. I just had that wrong. I was wondering why you were giving me that query. Yep, nope, should be 23. Any other questions besides that calculation error? We feel good with this here? All right. 23-24. Divide the 2 polynomials by synthetic division or long division. On the test, you have the choice to do synthetic or long division. You don't have to do it both ways. You just need to do it one. So if we look at number 20, I think the consensus is to do this by synthetic division. Now to do this by synthetic division, we'll set the problem up. We have the cubby and the line. And we take what we're dividing by and set it equal to 0. And we need to solve this for x, or the variable with the biggest exponent. So we would add 5 to both sides, telling us x is equal to 5. 5 is the number that goes inside the cubby. Now the numbers that go across the top are our coefficients. Any that are missing, we have to fill in as 0. Now our biggest variable is our x cubed. The number in front of it is 1. And we fill in going from there. So x cubed would be 1. Our x squared term would be negative 10. Our x term is 20. And the constant term is 26. Now, because there is no variables, there are no variables missing here, we don't have to fill any as 0. But if we didn't have the x squared extra constant term, if we're missing any of those, we do have to fill it in as 0. The number of numbers going across the top is always one more than the degree. Since the degree is 3, we should have 4, 1, negative 10, 20, and 26. We do have 4 numbers up there. They are all there. Now we can start this process. And the first thing we're going to do is 5 times 1, which is 5. Once we get that, we add the two numbers together. So negative 10 plus 5 is negative 5. Then we multiply this negative 5 by the number in the cubby. So 5 times negative 5 is negative 25. And then we add straight down. 20 plus negative 25 is negative 5. But now we multiply again. Our 5 times negative 5 is negative 25. Add 26 plus negative 25 is this one.
Oh, yeah.
This one. Now we fill in the remainder. Since we're dividing by 2 terms, our remainder should only have 1. So that last number is the remainder. The number in front of it, that first negative 5 is our constant term, our term without x. The next negative 5 is our term with x. Our 1 is our term with x squared. Telling us that the final answer is x squared minus 5x minus 5 plus 1 over what we were dividing this by. It is not going to be 5. Because what we're actually dividing it by is what? X minus 5. So the final answer is x squared minus 5x minus 5 plus 1 over x minus 5. Questions on this here? So we feel good with this problem here. Now I will tell you this, 20 through 24 in the full review video, I've already posted the full review video going through every single problem. Part of the reason the video is as long as it is that I did 20 through 24 bisynthetic and long division. I did both ways so that you can see both of the methods to do that. One of them I actually ended up doing 3 times, but that's part of the reason the video is so long. Is also I'm going through and explaining all of this. But do we feel good with number 20 by doing this division? Do we need to see 21 or 22?
Yes.
So we will need to solve the x minus 1 to get the number that goes inside the cubby. So for this one here, we would add 1 to both sides, telling us x is equal to 1. Now the numbers going across the top, we'd have 7 for x to the 4th, negative 10 for x cubed, 3 for x squared, 3 for x, and negative 3. And then we'd bring down the 7. And now we'll start this process. 1 times 7 is 7. Negative 10 plus 7 is negative 3. 1 times negative 3 is negative 3. Our 3 plus negative 3 is 0. 1 times 0 is 0. 3 plus 0 is almost 3. 1 times 3 is 3, and negative 3 plus 3 is indeed 0. So our remainder, constant term, term with x squared, term with x cubed, telling us that our final answer here is 7x cubed minus 3x squared plus 3. So we won't fill in the 0x because that's just 0. We don't have to include that in as part of our answer. That's still synthetic. Do we Any questions on 22? We feel good with 22. Let's look at 24. We're going to do it by long division. Yes. Now we can do these with synthetic division, but again, because we're dividing by a trinomial, we're dividing by a quadratic, the setup for synthetic division is different for these here because we would actually have two numbers in the cubby and two lines across. Here. Now once we get this set up, we take biggest term inside, and the biggest term inside for this here is 3x to the fourth, and we're going to divide it by the biggest term outside, which is x squared. 3x to the fourth divided by x squared, well, we'll still have the 3 because it's really 3 divided by 1. X to the fourth divided by x squared. When we divide like bases, we subtract the exponents. So x to the fourth divided by x squared, 4 minus 2 is 2, telling us the first term in our answer is 3x squared. Now the next thing we do is we take this term on top and multiply it by the term outside. Remove those two there. So we're going to take 3x squared and multiply it by our x squared minus x plus 3 to get what we're going to subtract or take away from what's inside. 3x squared times x squared is 3x to the fourth. 3x squared times negative x is going to be negative 3x cubed. And 3x squared times 3 is going to be plus 9x squared. So that can go away. And now we put it. Now you can do this by long division or synthetic division. And then we're going to subtract. 3x to the fourth minus 3x to the fourth is 0. Negative x cubed minus negative 3x cubed. Well, our negative and negative would make a positive, so x cubed plus 3x cubed would be 4x cubed. 8x squared minus 9x squared, 8 minus 9 is going to be negative x squared. And since we finished subtracting with the first part, we bring down our next term of 5x. And we do this again. So now we're going to take the biggest term inside and divide it by the biggest term outside. Biggest term inside now is 4x cubed. Biggest term outside is x squared. So we're going to take 4x cubed and divide it by x squared. Well, 4 divided by 1 is 4. X cubed divided by x squared, 3 minus 2 gives us 1. Telling us that the next part of our answer is going to be positive 4x. Now we take that 4x and multiply it by what's outside. So we're going to take 4x and multiply it by the x squared minus x plus 3. Now 4x times x squared is going to be 4x cubed. 4x times negative x is negative 4x squared. And 4x times 3 is going to be plus 12x.
So we have an hour for one of these questions on the test? Or?
Nope. All right, guys, focus. Then we subtract 4x cubed minus 4x cubed. 4 minus 4 is 0. Negative x squared minus negative 4x squared. Well, the negative and negative make a positive, so negative x squared plus 4x squared, negative 1 plus 4 is 3x squared. 5x minus 12x, 5 minus 12 is negative 7. And lastly, we bring down the plus 3, so we've got to do this one last time. Biggest term inside is 3x squared. Biggest term outside is x squared. So we're taking 3x squared divided by x squared. X squared divided by x squared is 1. 3 times 1 is just 3. So lastly, we need to multiply 3 by our x squared minus x plus 3. 3 times x squared is 3x squared. 3 times negative x is negative 3x. And 3 times 3 is plus 9. And then we subtract. 3x squared minus 3x squared is 0. Negative 7x minus negative 3x. Well, the negative and negative make a positive, so negative 7x plus 3x. Negative 7 plus 3 is negative 4x. And 3 minus 9 is negative 6. Now, because there are no numbers to bring down, this is our remainder. Our remainder for this is negative 4x minus 6. So we have our plus 3 here. So 3x squared plus 4x plus 3 is our whole part, and we do have to add the remainder, our negative 4x minus 6, over what we were dividing it by, x squared minus x plus 3. Questions on 24? Questions on how we do this here? Now, if you want to do one like 24 or 23 by synthetic division, I have a feeling y'all want to see this here. If we do a problem like this by synthetic division, we do have to get the x squared plus 4x minus 2, the x squared by itself. So if we're doing this by synthetic division, we've got to solve the quadratic for x squared. So the first thing we'd have to do here is add 2 to both sides, telling us that x squared plus 4x is equal to 2. We then also have to move the 4x over, telling us that x squared is equal to negative 4x plus 2. Questions on this so far? Now we need the 2 coefficients from this here and put both of those in the cubby. We have the negative 4 from the x, and we have the 2 from the constant. There are 2 separate terms, and we put them both in the cubby. Now we also have the numbers, our coefficients, going across the top. Now we're going to get 2 for x to the 4th, 8 for x cubed, negative 5 for x squared, negative 4 for x, and 2. And once we have that set up, because we do have 2 lines, the first number goes all the way down. Second number goes down below the first line. And we have this set up here. Now the negative 4, when we do the multiplication, its products are going to go above the second line. The 2, the constant terms products, are going to go above the first line. And we always multiply by the number under the second line. So the first thing we're going to multiply is negative 4 times our 2. And negative 4 times 2 is negative 8. We put it above the second line under our number. So we put the negative 8 under the 8. Then we're going to do 2 times the 2 on bottom. 2 times 2 is 4. We put it above the first line under that next number. And at this point here, we're going to add. So we're going to have to add the 8 and negative 8. And our 8 plus negative 8 is 0. Our other spot we're adding is the negative 5 plus 4. And negative 5 plus 4 is negative 1. Now we're going to do the multiplication again. But this time we're multiplying the negative 4 with the 0. And negative 4 times 0 is 0. We're also going to do 2 times 0, which is 0. And just like before, we're going to add, so we have negative 1 plus 0. And negative 1 plus 0 is negative 1. Negative 4 plus 0 is negative 4. Now we have to do this multiplication one last time. Now we're going to do negative 4 times our negative 1, which is 4. And lastly, 2 times negative 1 is negative 2. Now we need to add these here. Negative 4 plus 4 is 0. 2 plus negative 2 is 0. Because we have no other numbers up there on top, it means we are done. We have finished doing this by synthetic division. And to get our answer, we will need to bring that 0 down. We do need to bring those terms down that didn't come all the way to the bottom because we are done. Now, to determine our remainder, we're dividing this by 3 terms. We have the x squared, x, and constant term, which means our remainder has to have 2 terms. So our last 2 numbers below the bottom line are a part of the remainder. So these last 2 zeros are a part of the remainder. To be more specific, the first one is our constant, and the one in front of it would be our term with x. If there were 3 terms in the remainder, constant x, x squared. We still increase that. Now, once we get outside the remainder, the negative 1 is our term without x. Our 0 is our term with x. 2 is our term with x squared. So it tells us our answer for this here is 2x squared minus 1. We don't fill the remainder in because it's zeroed both. Nothing to write there. So just 2x squared minus 1. I'd say the hardest part about doing synthetic with this here is getting it set up and making sure to multiply and add the correct terms. Questions on this so far? For problems 25 and 26, we want to find the rational zeros. We want to find all possible rational zeros. Now, we're not actually solving this. We're just trying to find our plus or minus p over q, where p is the factors of the constant term, and q is the factors of the leading coefficient. Now, the constant term in our case is 27. So the factors of 27, well, we have 1 and 27, 3 and 9. So factors of 27, we're looking for the numbers that multiply together to give us 27. 1 and 27, 3 and 9. Now q is the factors of the leading coefficient, the numbers in front of the variable with the biggest exponent. And that number is 9. Now our factors of 9, we have 1 and 9 or 3 and 3. Now even though 3 shows up as a factor twice, we're only going to list it once. Now we need to list out all of our values of p over q, and we will put the plus or minus. Now the first number I always divide every value of p by is 1, the first value of q, which is really just going to give us the values of p back. So we should get plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27. And then I'm going to repeat this process with 3. So the first one we're going to have is 1 over 3, which is 1/3. It's not repeated. It doesn't reduce. So we have that there. Our next one is going to be 3 over 3. Well, 3 divided by 3 is? It's already listed. We're not writing it again. The next one's going to be 9 divided by 3, and 9 divided by 3 is 3. It's already listed. We're not writing it a second time. And lastly, with 3, we have 27 over 3, which is 9. Already listed, not writing it again. And then we're going to do the same thing with 9. So we have plus or minus 1/9. Then we move on to 3. Well, 3/9 reduces to what? 1/3. It's already listed. We don't have to write it a second time. 9/9 reduces to 1. It's already listed. And 27/9 reduces to 3. So the rational zeros for this here is positive negative 1, 1, positive negative 3, positive negative 9, positive negative 27, positive negative 1/3, and positive negative 1/9. So we do have to have all those listed. You do need the plus or minus. If you just put 1, 3, 9, 27, 1/3, 1/9, you are missing half of the solutions. We will finish this tomorrow. Your